Smart Culture, Mathematics.
Now, previously we've learned about arithmetic sequences, and we used this formula Tn is equal to a plus n minus 1 in brackets d to determine the rule for the nth term. So this was all for linear sequences, and in today's lesson we'll move on to quadratic sequences. How do you think is a quadratic sequence different from a linear sequence? A quadratic sequence is a sequence of numbers in which the second difference between any two consecutive terms is constant. So it will not be the first difference as in linear sequences. In this case, only the second difference will be constant. So let's take a look at this example. 0, 7, 18, 33, and 52. So what we'll do first is we'll take a look at the first difference. The difference between 0 and 7 is equal to 7. The difference between 7 and 18 is equal to 11. The difference between 18 and 33 is equal to 15. And the difference between 33 and 52 is equal to 19. So now we have 7, 11, 15, and 19. Let's move on to the second difference. Now we want to determine the second difference, and you'll see that there is a constant second difference. The difference between 7 and 11 is 4. The difference between 11 and 15 is also 4. And the difference between 15 and 19 is also 4. So here we have the first difference, and here we have the second difference. So instead of using the formula Tn is equal to a plus brackets n minus 1d, we'll use a new formula because this is a different kind of sequence. This is a quadratic sequence. We'll use the formula Tn is equal to an squared plus bn plus c. So how can we go about determining the value for a, b, and c? So what we do is we write 2a next to the line of second differences, and we write 3a plus b next to the line of first differences. So first we'll take a look at the line of second differences, and now we want to determine the value for a. 2a is equal to 4. We want to solve for a, so we divide both sides by 2. That means a is equal to 2. Now we take this value of a and we use it when we move on to the line of first differences. So here we have 3a plus b is equal to 7, and we know that the value for a is equal to 2. We've determined it previously. So then we sub in the value of a, which is 2, into this formula. Then we have 3 times 2 plus b is equal to 7. 3 times 2 is equal to 6. Remember, we want to solve for b, so we move the 6 over to the other side. So you'll see that b is equal to 1. So we have the value for a, we have the value for b. Now we want to determine the value for c. So a plus b plus c is always equal to the first term in a quadratic sequence. And in this case, the first term is equal to 0. A plus b plus c is equal to 0. We know that the value for a is equal to 2. We know that the value for b is equal to 1. We don't know the value for c. We want to determine the value for c. So we have 2 plus 1 plus c is equal to 0. 2 plus 1 is 3. Then we take this 3 over to the other side. So ultimately you'll see that c is equal to negative 3. So now we have the value for a, we have the value for b, and we have the value for c. So we can just sub in these values into the formula for a quadratic sequence. Tn is equal to an squared plus bn plus c. A is equal to 2, b is equal to 1, so we don't write it, and c is equal to negative 3. So the rule for this quadratic sequence will be 2n squared plus n minus 3. Now let's test this rule to see if it is correct. So we know that the value for the second term is 7. So what we'll do is we'll use this to determine if our rule is correct. So instead of writing n, we write 2. Because we want to determine the value for the second term. Then we have 2 times 2 squared plus 2 minus 3. 2 squared is equal to 4, so then we have 2 times 4 plus 2 minus 3. 2 times 4 is 8. Then we have 8 plus 2 minus 3. Now we know that 8 plus 2 is equal to 10, so then we have 10 minus 3, and that equals 7. And as you can see, the second term is indeed equal to 7, so we know that this rule is correct. How about this next example? Here we have 6, 9, 14, 21, and 30. And what we have to do is we have to determine the value for the 10th term. So what we'll do first is we'll determine the rule for the nth term, and then we can use that rule to determine the value for the 10th term. So remember, we have to use the formula an squared plus bn plus c. So tn is equal to an squared plus bn plus c. Let's take a look at the sequence. First, we'll determine the first difference. So 9 minus 6 is equal to 3, 14 minus 9 is equal to 5, 21 minus 14 is equal to 7, and 30 minus 21 is equal to 9. So here we have the first differences. Now let's determine the second difference. 5 minus 3 is 2, 7 minus 5 is 2, 9 minus 7 is 2. So here in the line of the second differences, we'll write 2a is equal to. Here in the line of first differences, we'll write 3a plus b is equal to. And here in the line of the sequence, we'll write a plus b plus c is equal to. Because we know that a plus b plus c is equal to the value of the first term. Now let's start with the line of second differences. What we want to do is we want to determine the value for a. So 2a is equal to 2. That means a is equal to 1. We want to solve for a, so we divide both sides by 2, and then we get an answer of 1. A is equal to 1. Let's take a look at the line of first differences. 3a plus b is equal to 3. Now we know that a is equal to 1, so we can sub this in. Then we have 3 times 1 plus b is equal to 3. If you take over the 3 to the other side, it will become a negative 3, so b has a value of 0. Now we want to determine the value for c. A plus b plus c is equal to 6. We know that a is equal to 1, b is equal to 0. So then we have 1 plus 0 plus c is equal to 6. Now we want to solve for c, so we'll take over the 1 to the other side. 6 minus 1 is equal to positive 5. So c is equal to 5. Now we have the value for a, we have the value for b, and we have the value for c. So we can just sub these into the formula. An squared plus bn plus c. So then we have n squared plus 5. This is the rule for the nth term. Let's test this to see if it's correct or not. So we know the value for the first, second, third, fourth, and fifth term. So you can use any of these to determine if your rule is correct or not. So let's use the value for the fifth term. So let's say we want to now determine the fifth term using this rule. So instead of n, we'll write 5. 5 squared is equal to 25. 5 times 5 is equal to 25. Plus 5 is equal to 30. And you can see this is indeed the value of the fifth term. So our rule is correct. Now remember, we want to determine the value of the 10th term. So we'll sub in the value of 10. 10 squared plus 5. 10 squared is equal to 100. 100 plus 5 is equal to 105. So this is the value of the 10th term.
And that's a wrap on today's fascinating journey through the world of knowledge. Don't forget to hit that subscribe button and join our ever-growing community of curious minds. We can't wait to embark on new educational adventures together.